projects. In this video, we are going to explain about the project titled Deep Ensemble-Based Efficient Framework for Network Attack Detection. Introduction. Networking plays a crucial role by enabling devices to communicate, share data, and access resources. It's integral to various aspects of life, including business operations, education, and daily activities. Despite its benefits, networking introduces security risks that can compromise data integrity, confidentiality, and system availability. These vulnerabilities need attention to ensure safe network usage. Network attacks such as malware, hacking, phishing, and denial of service pose serious risks including data theft, system disruptions, reputation damage, and financial losses. To counter these risks, an automated attack detection system based on artificial intelligence (AI) is crucial. AI can efficiently analyze network data for signs of attacks and respond rapidly. The project introduces an ensemble model that combines three deep learning models: LSTM, long short-term memory, RNN, recurrent neural network, and GRU, gated recurrent unit, using majority voting criteria. This ensemble approach aims for high accuracy network attack detection, strengthening network security. Objective. The primary objective of the project is to enhance the security of computer networks by efficiently detecting and responding to a variety of network attacks, including intrusions, malware, and data breaches. This proactive approach aims to protect sensitive data and ensure network integrity. The project includes an important goal of assessing the performance of the proposed framework by comparing it against existing state-of-the-art methods. This evaluation demonstrates the superiority of the framework in terms of accuracy, affirming its effectiveness in identifying and countering network attacks. The project's framework is designed to combine the power of artificial intelligence and deep learning models such as LSTM, RNN, and GRU. These models work in synergy, and the ensemble method, particularly majority voting, is used to enhance the accuracy of network attack detection. This approach provides a robust solution for network security. Utilizing the NSL-KDD dataset, the project's Ensemble Deep Voting Classifier (EDVC) achieves an exceptional accuracy score, surpassing the performance of other methods. This accomplishment underscores the framework's proficiency in identifying and mitigating network attacks, making it a valuable tool for network security. Software and hardware requirements. Software requirements of the project are: application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite. Front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements of the project are: operating system of Windows, processor of i5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Working modules or flow of work. To implement this project, we have designed the following steps. The first step is importing the packages. In this initial step, the necessary Python packages and libraries are imported. These packages include those for data manipulation, pandas, deep learning, keras, and data visualization, seaborn, and matplotlib. Exploring the dataset, KDD. This phase involves loading and exploring the KDD dataset. Data exploration includes examining the dataset structure, data types, and an initial overview to understand the content and characteristics of the data. This step is crucial for understanding the data to be used for network attack detection. Data processing. Pandas data frame. The dataset is typically loaded into a Pandas data frame. This data structure facilitates data manipulation and analysis. Keras processing. Keras, a deep learning framework, may be used for data pre-processing steps related to deep learning model requirements. Dropping unwanted columns. In some cases, columns in the dataset that are irrelevant to the network attack detection task may be removed to simplify the data and improve processing efficiency. Visualization using seaborn and matplotlib. Data visualization is a key step for gaining insights from the dataset. Seaborn and matplotlib are Python libraries used for creating data visualizations. This step involves generating plots and charts to visualize data distributions, relationships, and patterns within the dataset. Label encoding using label encoder. In the context of machine learning and deep learning, categorical variables need to be converted into numerical format. The label encoder is a tool to assign a unique numerical label to each category in the target variable, facilitating model training and prediction. Feature selection. Select percentile using mutual info classify. Feature selection is a crucial step to identify the most relevant features for the network attack detection task. In this case, the select percentile using mutual info classify method is employed to select the most informative features based on their mutual information with the target variable. This helps streamline the dataset for model training. Splitting the data to X and Y for machine learning. The dataset is divided into two parts, commonly referred to as X and Y. X represents the features or attributes used for prediction, while Y represents the target variable. This split prepares the data for machine learning model training, where X is used to predict Y. Building the model. At this stage, machine learning models are constructed using the training data X and Y. The models can be various algorithms such as deep learning models, example LSTM, RN and GRU, which are designed to learn from the data and make predictions about network attacks. As an extension, we applied an ensemble method combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Training and building the model. This step emphasizes the training aspect of the model building process. Models are trained on the provided data to understand patterns and relationships between features and network attacks. Flash framework with SQLite for sign-up and sign-in. The Flash framework, used in conjunction with SQLite, facilitates user management, including sign-up and sign-in functionalities. This ensures secure access to the system. User gives input as feature values. Users provide input data in the form of feature values. These values likely represent network traffic data or related information which will be used for network attack prediction. The given input is pre-processed for prediction. The provided user input is pre-processed to ensure it is in the correct format for making predictions. Data pre-processing may include data cleaning, validation, and any necessary transformations. Trained model is used for prediction. The machine learning or deep learning models trained in earlier steps are utilized to make predictions based on the pre-processed user input. These models have learned to identify patterns of network attacks. Final outcome is displayed through front end. The results of the prediction indicating whether a network attack is detected or not are displayed through the front end. Users can interact with the system through a user-friendly interface to access the outcome of the network attack detection process. Algorithms used. To implement this project, we have utilized the following algorithms. The first algorithm is machine learning with K-fold. K-fold cross-validation is a technique for assessing a model's performance. It involves splitting the dataset into K subsets, training the model on K1 of them, and testing on the remaining subset. This process is repeated K times to obtain more robust performance metrics. Logistic regression. Logistic regression is a binary classification algorithm used to model the probability of a binary outcome. It's effective for tasks where the target variable has two classes, such as network attack detection. SVM, support vector machine. SVM is a powerful classification algorithm that works well for both linear and non-linear data. It finds a hyperplane that best separates data points of different classes. Naive Bayes. Naive Bayes is a probabilistic classification algorithm based on Bayes' theorem. It's particularly effective for text classification tasks, but it can also be used for network attack detection. Random forest. Random forest is an ensemble learning method that combines multiple decision trees to improve prediction accuracy and reduce overfitting. It's versatile and can handle various types of data. Stacking classifier. Stacking is an ensemble method where multiple models such as random forest, RF, extra tree ET, and light GBM are combined. A meta-learner combines their outputs, resulting in a more robust final prediction. Voting classifier. A voting classifier combines the predictions of multiple Bayes classifiers such as random forest RF and AdaBoost AB. It aggregates their outputs and the majority vote decides the final prediction. Deep learning. Deep learning involves neural networks with multiple hidden layers. These networks can learn complex patterns in data and are particularly effective for tasks like image classification and natural language processing. CNN, Convolutional Neural Network. CNN are used primarily for image and spatial data analysis. They use convolutional layers to automatically extract features from images. In this context, CNN may be used for analyzing network traffic data. LSTM, Long Short-Term Memory. LSTM is a type of recurrent neural network RNN known for its ability to capture long-term dependencies in sequential data. It's useful for time series data and sequences which may be relevant for network attack detection. GRU, Gated Recurrent Unit. GRU is another type of recurrent neural network similar to LSTM but computationally more efficient. It's designed to capture dependencies in sequential data and can be used for similar tasks as LSTM. RNN, Recurrent Neural Network. RNN is a family of neural networks that process sequential data. It has applications in a wide range of tasks involving sequences, including network attack detection, where historical data can be crucial. Comparison graph. This is the accuracy comparison graph. On the x-axis, we have the accuracy score, and on the y-axis, we have the algorithm name. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances, both true positives and true negatives, to the total number of instances. This is the precision comparison graph. On the x-axis, we have the precision score, and on the y-axis, we have the algorithm name. Precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions, true positives plus false positives. This is the recall comparison graph. On the x-axis, we have the recall score, and on the y-axis, we have the algorithm name. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances, true positives plus false negatives. This is the F1 comparison graph. On the x-axis, we have the F1 score, and on the y-axis, we have the algorithm name. F1 score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is IPYNB file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we will copy the path of the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. Here I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is this localhost, and port, which is this. Now copy this local link provided by the Flask framework. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. This is the homepage of the project displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on log on. Here we need to enter all these details to register, but I have already registered, so click on sign in. Here we need to enter the username and the password which we have created, and then click on sign in. We have logged in successfully. Here we need to enter all these parameters. After entering all these parameters, we will predict whether the attack is detected or not. So I'm entering the parameters. So here I have entered all these parameters. Protocol type is 0. Protocol type identifies the network protocol used in a connection like TCP or UDP. Service is 13. Service indicates the specific network, service or application such as HTTP or FTP. SRC bytes is -0.00303. It represents the data byte sent from the source to the destination. DST bytes, that is destination bytes, is -0.02629. It represents the data bytes received by the destination from the source. Logged in is -0.4179. It indicates if a user is logged into the system or not. Count is -1.55426. It shows the number of connections to the same host in the past 2 seconds. SRV count is -1.18506. It represents the connections to the same service in the past 2 seconds. SRV different host rate is -0.20363. It reflects the proportion of connections to different hosts for the same service. DST host count is -3.5751. It displays the number of unique destination hosts in the past 2 seconds. DST host SRV count is -1.76976. It shows the number of unique destination hosts using the same service. DST host same service rate is 0.5939. It reflects the proportion of connections to the same service on the destination host. DST host different SRV rate is -0.28287. It represents the proportion of connections to different service on the destination host. DST host same SRC port rate is 0.82704. It reflects the proportion of connections from the same source port on the destination host. DST host SRV different host rate is -0.1586. It shows the proportion of connections to different destination hosts using the same service on the destination host. After entering all these parameters, click on predict. Here we can see we got the result. There is no attack detected and it's normal. We will enter another set of parameters and check whether attack is detected or not. So I'm entering another set of parameters now. Here we have entered another set of parameters. After entering all the parameters, click on predict. Here we can see we got the result attack is detected and it's R2L attack. Let us enter another set of parameters now. I'm entering. So here I have entered another set of parameters. Now click on predict. Here we can see we got the result attack is detected and it's DOS attack. In this way, by entering all the parameters, we can predict the attack type. Now click on logout. The conclusion of the project is the project uses deep learning models including LSTM, RNN and GRU to strengthen network attack detection and enhance computer network security. The evaluation of the framework using the NSE KDD dataset confirms its effectiveness in detecting network attacks with high accuracy, demonstrating its real-world applicability. Deep learning models and ensemble techniques make the framework adaptable, enabling it to learn and evolve with changing attack patterns. This adaptability reinforces the network's resilience against emerging threats. The heightened accuracy of the framework minimizes false alarms, allowing network administrators to focus on genuine threats. This optimization saves valuable resources and enhances security management.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.